In this video, we will be going over the answers to the electrostatics charge and electrostatics Coulomb's law worksheets. For electrostatics charge, question 1, the diagram below represents two electrically charged spheres, A and B. If the spheres are brought into contact, which sphere will have a net gain of electrons? So if we bring these two spheres into contact, because they are metal spheres, they are conductors, electrical charge will conduct across them and equalize across the identical spheres. Because we have a net charge of positive 2 times 10 to the negative 7 and positive 1 times 10 to the negative 7, that gives us an overall charge of positive 3 times 10 to the negative 7. Divided in half for each of the objects, this one will go down to 1.5, this one will go up to 1.5. Because it's asking us which one has a gain of negative electrons, it's asking us which one becomes more negative. A goes from positive 2 to positive 1.5. That becomes more negative. So the answer is 1, A only. Number 2. Metal sphere A has a charge of negative 2 units, and an identical sphere B has a charge of negative 4 units. If the spheres are brought into contact with each other and then separated, the charge on sphere B will be, we have a net charge of negative 2 on sphere A, negative 4 on sphere B. Together, that makes a net charge of negative 6, but it is divided amongst sphere A and B. Because they are identical, it is an even distribution, so the answer is going to be 3, negative 3 units. Number 3, if an object has a net charge of 4 coulombs, the object possesses, we need to figure out how many more electrons or protons it has. Now, first off, it says it has a negative charge. That means it has more electrons, so we know it has to be answer 1 or 2. Now we have 4 coulombs, and we have to convert that into number of electrons. We're going to use Q equals NE for that, where Q is our 4 coulombs, N is the number of electrons we're trying to find, and E is the charge on one electron, 1.6 times 10 to the negative 19. So by taking 4 coulombs and dividing it by 1.6 times 10 to the negative 19, we get the correct answer of 2.5 times 10 to the 19th more electrons. For this next question, we need to base our answer on the information below. A lightweight sphere hanging from an insulating thread. A student wishes to determine if the sphere is neutral or electrostatically charged. She has a negatively charged hard rubber rod and a positively charged glass rod. She does not touch the sphere with the rod, but runs tests by bringing them near the sphere one at a time. We need to describe test results that would prove if it's neutral. So she has a positively charged object and a negatively charged object, and this lightweight sphere that we're trying to determine what it is. If something is oppositely charged, it will attract. If it is charged the same, it will repel. There is one thing that we haven't mentioned there, and that's if it's neutrally charged. If we have an object that is neutrally charged, it will polarize, meaning the opposite charges will get attracted to the near side, and the like charges will get repelled to the far side. I'm actually going to skip down to number 12 because this is a great example of it. The diagram below shows 3 neutral metal spheres, X, Y, and Z, in contact on insulating stands, which diagram represents the charge distribution on the spheres when a positively charged rod is brought near the sphere X but does not touch it. Here we have our positively charged rod that is near the sphere. We know the negative charges and positive charges are inside of these spheres because these spheres are made of atoms, and atoms are always made of positives and negatives. The positively charged rod will attract negatives in the metal. So we will have negatives near this positively charged rod. So that means number 1 is wrong because we show positives getting attracted, and that's wrong. Number 3 is wrong because it shows positives being attracted, and that's wrong. That leaves us with either 2 or 4 as being correct. The answer is going to be 4. Simply because these are metal objects in contact with one another, the charges can flow freely between them. So we're going to get all of the negatives from object Z are going to move through object Y and deposit themselves on object X. And object Y will become polarized. This is what I mean when I say the word polarize. You have negative charges on one side, positive charges on the other. Going back up here to number 4, if our object is attracted to a negative rod, that means the object in question has to either be positive or neutral. If it is attracted to a positive rod, the object in question has to be either negative or neutral. If it is attracted to both, positive and negative, the only result that would make sense would be for it to be neutral. Number 5, describe the test result that would prove the sphere is positively charged. If it is repelled from a positively charged object, then it is positively charged. You can really only tell what something is based on the repulsion, because if it is attracted, it could be oppositely charged or it could be neutral and just polarized. Number 6. We have oil droplets that gain an electrical charge when they're projected through a nozzle. Which quantity of charge is not possible for an oil droplet? You're just looking at which of these values is not an even multiple or a whole number multiple of the electrostatic charge on an electron. So 8 times 10 to the negative 19, 4.8 times 10 to the negative 19, 3.2 times 10 to the negative 19, or 2.6 times 10 to the negative 19. The answer here is 2.6, because that is more than 1 but less than 2 electric charges. You cannot have half an electron, and this would be 1 and a bit of an electron. Number 7, a positive test charge is placed between an electron E and proton P as shown in the diagram below. When the test charge is released, it will move towards, this is positive, the proton is positive, the electron is negative. Positive charge will get pushed away from the positive and towards the negative. The answer there is D. It will get pushed towards point D on the diagram. A metal sphere has a net negative charge of 1 times 10 to the negative 6 coulombs, approximately how many more electrons than protons are on the sphere. This one is like number 3, where we're going to use Q equals NE. We know Q is going to be this charge of 1.1 times 10 to the negative 6th. We know E is 1.6 times 10 to the negative 19th. We take 1.1 times 10 to the negative 6th divided by 1.6 times 10 to the negative 19th, and we get the answer as 6.9 times 10 to the 12th. Be very careful when you're dividing things with scientific notation in your calculator. Put the entire numerator in a big parenthesis, so open parenthesis, 1.1 times 10 to the negative 6th, close parenthesis, divided by, and put the entire denominator in a parenthesis. So you'll do divided by, open parenthesis, 1.6 times 10 to the negative 19th, close parenthesis. If you don't do it that way, your calculator will try to do the order of operations and will do multiplication and division going left to right, because you did not put things in groupings, did not put things in parentheses. Number 9, a positively charged glass rod attracts object X. The net charge on object X, well, if it's attracted to if it's attracted to the positively charged rod, object X could be negative, but it could also be neutral and just be polarized. So number 9 is going to be answer choice 1. Number 10, the charge to mass ratio for an electron is, you're taking the charge of an electron divided by the mass of an electron. So 1.6 times 10 to the negative 19th divided by the mass of an electron, which was provided for you in the notes. And we get number 3, 1.76 times 10 to the 11th coulombs per kilogram. What is the magnitude of the charge in coulombs of a lithium nucleus containing 3 protons and 4 neutrons? So 3 protons would be 3 positive charges. 4 neutrons are neutral, so there's no other charges. So you're going to use Q equals NE, where N is 3 and E is 1.6 times 10 to the negative 19th. Already talked about number 12 here. Number 12 is this answer choice down here, number 4. Number 13, when the net electrical charge on a magnesium, what is the net electrical charge on a magnesium ion that is formed when a neutral magnesium atom loses 2 electrons? It loses 2 electrons, so it becomes positive. So it's going to be either 3 or 4. We have 2 electron difference, so we're going to do Q equals Ne, where N is 2, and we get 3.2 times 10 to the negative 19th coulombs. Number 14. A negatively charged plastic comb is brought close to, but does not touch, a small piece of paper. If the comb and the paper are attracted to each other, the charge on the paper must be, they're attracted, it's either opposite or neutral. So negatively charged plastic comb could be negatively charged paper or neutral paper. I'm sorry, could be positively charged paper or neutral paper. Number 15, an object possessing an excess of 1.6 times 10 to the 6th electrons has a net charge of, we're going to use Q equals Ne again, where N is the 6.0 times 10 to the 6th, multiply it by 1.6 times 10 to the negative 19th, and we get the answer of 9.6 times 10 to the negative 13th. Number 16. When a neutral metal sphere is charged by contact with a positively charged glass rod, the sphere, so if we have, gotta imagine that we have a neutral sphere, and we touch it with a positive rod, the positive rod is going to take some electrons off of the sphere and put them on the rod to cancel out the positive. That will leave behind a positive charge on the sphere. But if the sphere became positively charged, that means it must have lost electrons, which is that answer choice there. Which quantity of excess electrical charge could be found in an object? Again, we're dealing with elementary charges. We can only have even multiples of 1.6 times 10 to the negative 19th. We can't have 6 1/4 electrons. We can't have 1.6 electrons. We have to have, in this instance, 3 electrons. Number 18, a particle could have a charge of, again, dealing with that whole number multiple of the elementary charge, 3.2 times 10 to the negative 19th. We can have 2 electrons. We can't have half an electron. We can't have 3/4 of an electron. We can't have 2 and a bit of an electron. We have to have exactly 2 electrons, or 3 electrons, or 4 electrons. Number 19. A dry plastic rod is rubbed with wool cloth and then held near a thin stream of water from a faucet. The path of the stream of water is changed as represented by the diagram below. Which of the following causes the path of the stream of water to change? That is the electrostatic attraction, because the water is going to be polarized and going to be attracted to the plastic rod. Number 20. Which net charge could be found on an object? Again, dealing with Q equals Ne, these are the different Q's we have. N has to be a whole number integer. Cannot be a fraction of an electron. 4.8 times 10 to the negative 19th is the correct answer because that is 3 electrons, or actually a deficit of 3 electrons because it's positive. Number 21, 2 identically sized metal spheres A and B on insulating stands as shown in the diagram below. Sphere A possesses an excess of electrons and sphere B is neutral. Which diagram best represents the charge distribution on sphere B? So this possesses electrons. It is negative. So we are going to see in sphere B that negative charges get pushed away and positive charges get attracted. Answer choice is going to be number 4. That again shows the concept of polarization. Number 22. 2 identically sized metal spheres on insulating stands are positioned as shown below. The charge on sphere A is negative 4 times 10 to the negative 6th coulombs, and the charge on sphere B is negative 8 times 10 to the negative 6th coulombs. The 2 spheres are touched together and then separated. the total number of excess electrons on sphere A after the separation is, together we have negative 12 times 10 to the negative 6th coulombs. If I bring them together, that charge will evenly distribute between A and B, and we will Yes, the charge will evenly distribute, and we'll get a net charge of negative 6 times 10 to the negative 6 coulombs. You'll notice that's not one of the answers, because that's not what the question asked. It asked for the total number of excess electrons. So you're going to then use Q equals NE to find the answer as 3.8 times 10 to the 13th. And that is it for the electrostatics charge worksheet. We're now going to move on to the electrostatics Coulomb's law worksheet. This one's a little bit longer, but we should be able to get through it. Number 1, which graph best represents the electrostatic force between an alpha particle with a charge of positive 2 charges and a positively charged nucleus as a function of their distance of separation? We're simply looking at F equals K Q1 Q2 over R squared. That is our equation for this. We're looking at how distance changes the force. If I increase the distance, if I increase the radius in the denominator, my electric force decreases. So as I get further along in the x direction here, a bigger distance, my electrostatic force needs to decrease. So that leaves me with either 1 or 2. 3 and 4, 3 shows an increasing relationship, a direct relationship between the electrostatic force and distance. And number 4 shows no relationship, that the electrostatic force is constant. So 3 and 4 are both wrong. That leaves us to 1 and 2. Well, 2 would be a negative direct relationship, whereas 1 is an inverse relationship because we are dealing with not a negative direct relationship. There's no negative sign in KQ1 Q2 over R squared, and R is not in the numerator. It's not going to be number 2. You could easily do this by just taking that equation and putting in your calculator, but getting rid of everything you don't care about. So electrostatic force is Y. So the Y equals is going to be our electrostatic force. And then the distance is going to be R, so that is going to be your x-axis, and that's in the denominator squared. So if you were to graph Y equals 1 over x squared, your graph would look like this. Number 2, in the diagram below, 2 positively charged spheres A and B of masses MA and MB are located a distance d apart. Which diagram best represents the direction of the gravitational force Fg and the electrostatic force Fe acting on the sphere A due to the mass of the charge? Note, the vectors are not drawn to scale. So we have 2 positively charged spheres. Opposites attract, likes repel. So the electrostatic force is going to be directed away from it. However, we have 2 objects with mass, and gravitational force will always be attractive. So we are going to say that the answer is 3. The electrostatic force is directed to the left, whereas the gravitational force is directed to the right. Number 3. What is the magnitude of the electrostatic force between 2 electrons separated by a distance of 1 times 10 to the negative 8th meters? You're going to use KQQ over R squared, where the 2 Q's are 1.6 times 10 to the negative 19th. The most common mistake I see students make with this equation is 1. They take the 2 charges and they add them instead of multiplying. 2, they forget that there have to be 2 charges. And 3, they forget to square the denominator. Be very, very careful when plugging this in your calculator because, again, we are dividing by scientific notation. And not only are we dividing by scientific notation, we're dividing by scientific notation that is then squared. So always think back to, does this answer make sense? You have 9 times 10 to the 9th times 1.6 times 10 to the negative 19th times 1.6 times 10 to the negative 19th divided by 1 times 10 to the negative 8th squared. 10 to the negative 8th in the denominator squared becomes 10 to the negative 16th. 10 to the negative 16th kind of cancels out with one of those 10 to the negative 19ths in the numerator, so that leaves us with a 10 to the negative 3rd and a 10 to the negative 19th in the numerator, which gives us a 10 to the negative 22nd. But then we're also multiplying it by a 10 to the positive 9th. Positive 9th, negative 22nd leaves us with 10 to the negative 12th. I know my answer is going to be 3. So I didn't even have to plug that in my calculator to get the answer there. Just by looking at the scientific notation, you can actually get pretty far. It's always a good idea to think through that scientific notation and what happens when I multiply them together or divide them to figure out if your answer is reasonable, because we are very, very, very bad at plugging scientific notation into our calculator. Number 4. Two metal spheres A and B possess charges of 1 microcoulomb and 2 microcoulombs. Micro is 10 to the negative 6th, respectively. In the diagram below, F represents the electrostatic force exerted on sphere B by sphere A, which arrow represents the magnitude and direction of the electrostatic force exerted by on sphere A by sphere B. So here we are dealing with an action-reaction pair. Sphere A pushes on sphere B with force F to the right. Sphere B pushes on sphere A with force F to the left. The answer is 1. Number 4. Two small identical metal spheres A and B on insulated stands are each given a charge of positive 2 times 10 to the negative 6 coulomb. The distance between the spheres is 1 times 10 to the negative 1 meters. Calculate the magnitude of the electrostatic force on the electrostatic force that the charge on sphere A exerts on the charge on sphere B. This is again F equals K Q1 Q2 over R squared. So we take this charge, we have to put that charge on both spheres, so that is both Q1 and Q2. And this is our distance in the denominator. We plug that in and we get 0.9 newtons. 9 times 10 to the negative 9th times 2 times 10 to the negative 6th times 2 times 10 to the negative 6th divided by 2 times 10 to the negative 1st squared. Number 6. A force of 6 times 10 to the negative 15th newtons due south and a force of 8 times 10 to the negative 15th newtons due east act concurrently on electron E. On the diagram, draw a force diagram to represent the two forces acting on the electron. The electron is represented by a dot. Use a ruler to give ourselves a scale. So you just need to make sure that you draw the arrow to the right as longer than the arrow south. Number 7, determine the resultant force on the electron graphically. Label the resultant vector R. So finding that resultant vector. Determine the magnitude of the resultant vector. You're going to use the Pythagorean theorem. That would give you 1 times 10 to the negative 14th newtons. And determine the angle between the 6 Newton vector and the resultant vector. So find this angle down here. You would get 53.1 degrees. We're not really going to do too much of this two-dimensional motion stuff. Number 10. The distance between an electron and a proton is varied. Which of the graphs represent the relationship between the gravitational force Fg and distance r in the relationship between electrostatic force Fe and distance r for these particles? This one, I don't believe we ever went into the gravitational force equation one. So the important thing to know is just that the electrostatic force is going to have this inverse square relationship. So 1 and 4 both have the correct electrostatic force diagram. Turns out that the gravitational force varies the same way with respect to radius. Number 11, which graph best represents the relationship between the magnitude of the electrostatic force and the distance between two oppositely charged particles? We've covered this twice already. It is number 4, inverse square relationship. The diagram below shows two identical metal spheres, A and B, separated by a distance d. Each sphere has a mass m and possesses a charge q. Which diagram best represents the electrostatic force and the gravitational force acting on sphere B due to sphere A? They have the same charge, So there's going to be a repulsive electrostatic force. So Fe is going to be directed to the right. So that means it's either 2 or it is 4. Gravitational force is always attractive, so the gravitational force is going to be directed to the left. Gives us the answer 2. Number 13, the diagram below shows an arrangement of 3 small spheres, A, B, and C, having charge Q, 3Q, Q, and Q, respectively. Spheres A and C are located at a distance r from B. Compared to the magnitude of the electrostatic force exerted by sphere B on sphere C, the magnitude of electrostatic force exerted by sphere A on sphere C is, sphere A is 3 times the charge of sphere B. So when we're doing kq1, q2 over r squared, that numerator is going to be 3 times bigger for A on C than it is for B on C. So we're going to have a 3 in the numerator. But the distance is twice as big, so the r is going to be doubled. But we have to remember that r is squared, so if we take a 2 and we square it, we get a 4. Number 3 will be 3/4 as great, which actually is smaller. But number 14. If the distance separating an electron and a proton is halved, the magnitude and the electrostatic force between those charges will be, if I decrease the denominator, my value will get bigger. I am decreasing the radius by a factor of 2. That gets squared. I'm decreasing the denominator by a factor of 4. That increases the total by a factor of 4. The answer is quadrupled. Easiest way to do some of these is just to plug in some numbers. So think of, what if r were 2? Then I would have a force of kq over 4. If I then cut that radius in half and that radius becomes 1, my equation becomes kq over 1, which is now 4 times bigger than the original. Number 15. 2 similar metal spheres A and B have charges of +2 and +1 times 10 to the -6 coulombs respectively, as shown in the diagram. The magnitude of the electrostatic force on A due to B is 2.4 newtons. What is the magnitude of the electrostatic force on B due to A? You could go down a whole long rabbit hole of figuring out what's the radius and then doing the calculation, but it doesn't matter. This is a Newton's third law question. Object A pushes on object B with the same force object B pushes on object A. So if A is pushed by B with 2.4 newtons, B is pushed by A with 2.4 newtons. The answer is 2. Number 16, 2 protons are located 1 meter apart. Compared to the gravitational force of attraction between the 2 protons, the electrostatic force between the protons is, not going to need to worry about this one. The answer is stronger and repulsive. They're 2 protons, so it's a repulsive force. The electrostatic force is actually much, 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 much greater than the gravitational force. Number 17. The diagram below shows 2 small metal spheres, A and B. Each sphere possesses a net charge of 4 times 10 to the -6 coulombs. The spheres are separated by a distance of 1 meter. Which combination of charged spheres and separation distance produces an electrostatic force of the same magnitude as the electrostatic force between sphere A and B? So we would need to do F equals kq1 q2 over r squared for this, and do the same thing for each of these to find the correct answer. I'm going to ignore k because k is the same for both of them, and if I multiply 2 things by the same thing, I get the same thing. So here I have 4 times 4 is 16 over 1. So I want 16 times 10 to the -12th as my answer. So this would be 2 times 2 is 4 divided by 0.4 squared. 0.4 squared is 0.16. So that would be, what did I say, 4 divided by 0.16? That's not my 16 that I was looking for. Here I have 6 times 4 6 times 4 is 24 divided by 0.8 squared. Let's do that. 0.8 times 0.8. 24 divided by 64. I don't think that's going to be what I'm looking for. So I keep doing that until until I get down to this one. I have 8 times 8 is 64 divided by 4. 64 divided by 4 is 16 times 10 to the negative 12th. 4 is my answer. So that one was just really a plug and chug is the easiest way to do it. Number 18. A balloon is rubbed against a student's hair and then touched the wall. The balloon sticks to the wall due to, that would be the electrostatic force between the particles on the balloon and the particles on the wall. So the answer there is 3. We have to have the balloon attracted to the wall. We can't just have the balloon's particles attracted to each other. And we haven't talked about magnetic forces. So, number 19, the magnitude of the electrostatic force between 2 point charges is F. If the distance between the charges is doubled, the electrostatic force will become F over 4. Yes, F over 4. So if I increase the denominator by a factor of 2, that 2 gets squared. It decreases the overall answer by 1/4. Number 20. In the diagram below, a positive test charge is located between 2 charged spheres, A and B. Sphere A has a positive charge of positive 2q and located 2 meters from the test charge. Sphere B has a charge of negative 2q and is located 0.1 meter from the test charge. If the magnitude on the force of the test charge due to sphere A is F, what is the magnitude of the force on the test charge due to sphere B? So because the charges are the same magnitude, this one is positive, this one is negative, but they're both 2q's. The numerators are the same for F equals kq1 q2 over r squared. Only thing that we're changing is the denominator. We're decreasing the denominator by a factor of 2. So we have a 1/2 in the denominator that gets squared. That gives us a 1/4 in the denominator, which will increase our overall value by a factor of 4. Again, you could just plug these in your calculator and find what this force is and then what that force would be. Number 21, 2 positively charged masses are separated by a distance r. Which statement best describes the gravitational and electrostatic forces between the 2 masses? The electrostatic force between 2 positive charges is going to be repulsive. Gravitational force is always attractive. The answer there is 4. Gravitational force attracts. The electrostatic force repels. Number 22. A distance of 1 meter separates the center of 2 charged spheres. The spheres exert gravitational force Fg and electrostatic force Fe on each other. If the distance between the sphere centers is increased to 3 meters, the gravitational force and electrostatic force, respectively, would be represented as, the answer there is 1. They both would have an r squared in the denominator. And really the only one we've talked about is the electrostatic force, so Fe. We can actually completely ignore Fg here. If we increase the denominator by a factor of 3, that 3 gets squared because it's r squared. We increase the denominator by a factor of 9. That gives us an answer of 1. Almost done. Base your answers to question 22 and 23 and 24 on the diagram below and your knowledge of on your knowledge of physics. The diagram represents 2 small charged identical metal spheres A and B that are separated by a distance of 2 meters. What is the magnitude of the electrostatic force exerted by sphere A on sphere B? Going to actually have to type it in our calculator this time. F equals kq1 q2 over r squared. We take 9 times 10 to the 9th times 1.6 times 10 to the negative 6 times 1 times 10 to the negative 6 divided by 2 squared. Make sure you square the denominator, make sure you multiply those two together. You'll notice that I kind of left off this negative sign. A lot of times we don't worry about the negative sign because all that negative sign and that positive sign tell me is that this force is going to be attractive. It does not tell me anything about the magnitude. So for number 23, my answer is 3.6 times 10 to the negative 3rd. Number 24, if the 2 spheres were touched together and then separated, the charge on sphere A would be ... we have to touch them together. That would equalize the charges and distribute the charge across the two. So if I look at my total charge, negative 1.6, positive 1.0, both times 10 to the negative 6, together that gives me a negative 0.6 times 10 to the negative 6th, which then has to be distributed between A and B, and I get negative 0.3 times 10 to the negative 6th, or negative 3 times 10 to the negative 7th. Number 25. Two electrons are separated by a distance of 3 times 10 to the negative 6 meters. What is the magnitude and direction of the electrostatic force each exerts on the other? Two electrons are separated. Because we have two electrons, the force is going to be away from each other. We're going to just plug in our calculator, k q1 q2 over r squared, and we get the answer of 2.56 times 10 to the negative 17th. Away from each other. Number 26, when 2-point charges of magnitude q1 and q2 are separated by a distance r, the magnitude of the electrostatic force between them is F. What would the magnitude of the electrostatic force between charges 2q and 4q when separated by a distance of 2r? So we are increasing our numerator by a factor of 8 because we would do 2 times 4 is 8. We're increasing the denominator by a factor of 4 because we would have 2r squared gives me 4r squared. So 8 divided by 4 is 2. The whole answer is increased by a factor of 2. Finally, when 2-point charges are a distance d apart, the magnitude of the electrostatic force between them is F. If the distance between the point charges is increased to 3d, the magnitude of the electrostatic force would be, if we're increasing the separation, we're decreasing the force. So it would not be 3 or 4. If we're increasing the radius by a factor of 3, that 3 gets squared because the radius is squared. We're decreasing by a factor of 9. The answer there is 1. So that'll do it for this video going over the electrostatics worksheets on electrical charges and Coulomb's law. Make sure you go back and review any questions that you had difficulty with, as we will be having a quiz on this, a spot check on this shortly.